Hi, everyone, and thanks for joining us today. Today, we're going to talk about some practical uses of AI with SAP. I guess often we hear a lot of conceptual discussion around AI and machine learning, but not often do we really hear an opportunity to see these tools in operation. And so today, our team from Think 180 are going to start showing you some practical applications of machine learning and AI. So we're going to hand over to Ryan and Michael from Think 180 to have a chat about a demo that they've prepared. All right, guys, over to you.
Hi, everyone. My name's Ryan, and I'm a full stack developer with Think 180.
Hey, everyone. I'm Michael, and I'm a data analyst at Think 180.
Fantastic. So we're going to start off with a demo, and then we'll talk a little bit about the demo, how the pieces work, and then some of our thoughts around how AI can work in a corporate environment with SAP. All right, guys, over to the demo.
So the purpose of this demo is to explore the power and potential of integrating machine learning in SAP. And in this particular case, we're going to attempt to automate some asset inspection using machine learning to analyze images that are submitted. So the first step in this process is a simple Fiori app where we can upload an image, and we'll be using machine learning to analyze the image for a defect. But before we do, let's hand over to Michael to give us some context on the scenario and what insulators are.
Thanks, Ryan. Can you just bring up the insulator slide there? Okay, cool. So very quickly, what is an insulator, first of all? So an insulator is what you can see in the photo there. I've got one here. Here's one I prepared earlier. And it's the thing that sits at the top of a telegraph pole and holds up the electrical cables for the grid. So they're crucial to the functioning of the network. And that's basically what they do. They just sit on the pole, hold up the network, the electrical cables, I should say.
Yeah, and as many of our participants know, that a critical part of the network, they need to be replaced and they get damaged. And one of the challenges in a business environment is to do the inspection and analyze insulators visually to see if there are defects. And so that's where we see the use of AI really becoming such a valuable tool. It's a high volume, very challenging thing for a human to do. So we're going to see how a machine and machine learning can assist us with this scenario. So now we're going to jump into a demo, and Ryan's going to run us through our demo, and then we'll talk a little bit further.
So in this particular use case, we'll be uploading an image using a simple Fiori app, and we'll be using AI to analyze that image and tell us whether it's defective or not. So here I'll be uploading an image of an insulator. Let's try a damaged insulator. And the objective of this is to have the image analyzed and a defect notification raised in SAP. So here we can see analysis is pending on the image. This can take up to a couple minutes. So while that's running, I'll let Michael talk a bit about what's happening under the hood.
Okay, thanks, Ryan. So what's happening here is it's being passed to this AI framework, and there's some analysis being performed on the image. So this is what we're seeing on the screen. There is actually a pre-recorded video that's been passed through this model, and we'll get to what that is in a minute. But basically, what's happening, the image is being passed into the framework, and the framework is doing some detection on this, and it's passing back what it thinks it's seeing. So on the screen there, you can see it's seeing a damaged insulator and a brown insulator. So we can talk a little bit about how that works. We'll get to that, but on the back end, that's what's happening. It's performing the analysis on what it's seeing.
Fantastic. So guys, looks very simple. Tell us a little bit about how this solution fits together. So you've got some SAP components in there. So you've got a Fiori screen, you've got some AI. Tell us a little bit about the solution architecture and how this tool set fits together.
I can. Yes, certainly. Okay, so basically we've got three components here. The front end is SAP Fiori, which Ryan can talk to, and we've got the SAP middle component, which is housing all the noties, and then the back end there, which what we saw is the actual AI component. So I can talk to that. Ryan, you're best placed to talk about the SAP and the Fiori components, I think.
Sure. So really the first step in this process is a Fury app, or any conceivable process that can input images into our SAP ERP system. From there, we'll be running a Tensorflow script using an include. Tensorflow runs in Python, and this is run through a batch job scheduled in SAP. Once the Python script finishes running, it will output a result into our batch job, which then updates a notification, which tells us the status of the asset. In this case, it's whether or not the insulator is functional.
Fantastic. And I guess, Michael, there's a tool in there called Tensorflow. Tell us a little bit about Tensorflow and what it does for us and how it works.
Sure. So Tensorflow is as the slide says, it's an open source software library. It's free. It's used for machine learning and AI. It's developed by Google. And what it basically allows, it allows for easy and quick building and deployment of all sorts of AI capabilities. It has APIs built into it, which allow you to build these scripts, which very quickly allow you to build models, train models, do analysis on models. There's a whole bunch of functionality built into it, which make it very quick and easy to use high-level languages like Python or C++ to harness the power of AI and machine learning.
So, I mean, it's a really good point, isn't it? So you're using TensorFlow, a lot of different providers out in the market. You don't have to go and buy serious technology to start looking at AI. There are readily available tools like TensorFlow that really you can just go and grab and start to work with models and developing an AI type solution, right?
Yeah, exactly right. There's other libraries out there. There's other frameworks. We've chosen TensorFlow in this instance, but exactly right. You don't need to go and buy this stuff. A lot of this capability is free and open source. There's a ton of material available on tutorials and guides and information. There's a wealth of information as to how to get started, how to harness it. So I'll just talk a little bit of very quickly on how it's used here. Basically, so we're using a pre-trained model. It's a TensorFlow pre-trained model. And what that is basically a neural network. So I'll do a very, very high 101 neural network overview. So basically what this allows you to do is train a neural network. It can learn by showing it data and then feeding back what it knows about that data. So we show it a damaged insulator, tell it it's seeing a damaged insulator, and then the neural network can learn, as it's called. And so what's happening inside there is all the ties between each neuron is actually the weights are being adjusted using a very complicated mathematical algorithm, backpropagation, to adjust all the weights in the model. So as you pass in images, you train the model repeatedly, and over time, as you pass in more and more data and train the model, for an extended period, the idea is that the model gets more accurate and better at predicting what it's seeing. So it's all about taking data and experience, basically vast volumes of data to train your model to get outputs which are sufficient.
All right, Michael, for those of us that don't know how to get going in these AI tools like TensorFlow, can you tell us a little bit about the process that you've gone through and a little bit of the under the covers of TensorFlow?
Sure. So it's surprisingly simple. What we're using here is this TensorFlow model, which is, as I say, this open source. It's a pre-trained model available to anyone. And then what we've done is gather up our custom data set. So in this instance, as I say, we've taken these insulators and labeled them. And the bottom left picture there is a picture of me labeling the data. You use certain tools to do that. You label the data, and then it's a matter of running the training script. So passing in the data in a particular format so that TensorFlow can work with it. And then you get enough data, I think. So we had 5 insulators and I think a couple of hundred photos of these insulators, all labeled. And then you run the training scripts and it passes the data through the model repeatedly. And over time, the model learns and gets more and more accurate to a point.
Fantastic. And I see on the right-hand side some code. Did you have to write some code as well?
Yes, yeah. So this I was using, as I say, TensorFlow can work in a number of high-level languages. In this case, we've used Python. So that's some of the Python script we're seeing there, which is using the TensorFlow framework.
Fantastic, fantastic. So I guess, guys, you've built a model, so you've got to integrate. You've got TensorFlow integrated to SAP. So this is something that people can really do. Ryan, perhaps we should jump back to you, and you can show us the result of your upload and processing.
Sure. So let's try giving this a refresh, see if the results come through. So it looks like the AI has analyzed this and come back with damage, which is a good result.
Fantastic. So it goes to show you that it really does work, and I reckon we can all see that that's a damaged insulator. So I think demo proven. Well done, guys. Now, I guess if we take this concept away, so we can see that this is doable, and you can integrate it to SAP, you can integrate it into your Noties. Tell us a little bit about, I guess some of the challenges that we face in taking this technology on.
Sure, so I can talk to that. So as you point out, the key here is to see that we've integrated SAP with the AI model. The AI model presents challenges in and of itself. So some of the key ones that I think need to be raised are things like knowing when and where to use machine learning. There's a lot of talk, or there's a lot of hype around machine learning at the moment. AI can be, this solve all issues. And yes, it can. There's lots of applications there. It's very powerful. And as you can see here, this, the kind of places this can be used can be very practical in a number of different areas. It's a question of knowing where and where not to use it, where it's applicable, because these sorts of algorithms, the machine learning algorithms, give you degrees of confidence. It's not your classic like binary output. It's going to give you degrees of confidence. It's a question of knowing, are you happy with a model that's 90% accurate, or do you need 99.9% accuracy? It's a question of knowing how much margin of error it will meet the requirement. So when and where to use machine learning, how to integrate it into your end-to-end solution.
Yeah, I think you hit the nail on the head there, and you've got a great scenario. But it's what you taught it, isn't it? So you taught it lots of healthy insulators, you taught it lots of broken insulators, and it'll only know what you taught it.
Yes, yeah, exactly right. It knows what it's been trained on. In practice, if it was to see something it didn't, if it hadn't seen before, the results might not be as confident. So it's those sort of edge cases in this particular scenario that you'd be looking to work through. It's knowing how to apply it, where to apply it, and its place in the end-to-end process.
Yeah, so it's not a silver bullet, but it's part of a tool set that can help us to be smarter. Cut down some of those really high volume, challenging tasks that we're not, as humans, we're not good at, and the machines can help us. But the good news is, for now anyway, we still need it, and but it's part of that toolkit.
Yes. Another challenge I'll quickly touch on is the actual training data itself. As we had those 5 insulators, so we had relatively small amount of training data, but that in a real world scenario, you need tons of data, and gathering that data, collating that data, labeling it. There's a lot of effort and manpower in doing that and maintaining that data set. And that's what these models are built on is their data. So there's a question of getting that data, and then also getting the model to a point that's, as I say, going to give you the kind of outputs that are sufficient. It's going to give you the margin of error that you're comfortable with. Getting the model in such a way, there is some skill required in getting the model to that point that it gives you what you need.
Fantastic. So Ryan, as you look at the project that you've done, and there's been all the different pieces that you guys have built into this demo. I guess what are the takeaways for you?
Major takeaway for this is just how powerful it is. It's really only limited by our imaginations. Just thinking now, imagine if we could have a drone flying down the street, taking photos of all the Stoby poles and automatically scheduling workers to come and fix them. Really, the amount of possibilities with this are endless, and I'm excited to apply it to future things.
Yeah, fantastic. And you guys have shown that you can take the technology the different pieces, and you can build it into your sort of business workflow. I mean, that's the most important thing. I mean, technology for technology's sake, is only part of the paradigm for us. It's about putting it all together and creating a business process around it. We live in this business world, and so it's about taking the SAP technology, the AI technology, and actually making it useful rather than just having a whole lot of acronyms that people don't really understand and a whole lot of concept. You guys have turned that into something very practical. Michael, what about you? What are your takeaways?
Much of what you say there, just how this technology can be harnessed within SAP. I mean, that really is one of the key points of this whole proof of concept we've done, is that you can integrate the SAP with these AI smarts. So, it's limited only really by, what your AI model can do, what your data set is, what you want it to do. And beyond that, it's, as Ryan says, use your imagination and how it might be applied. The other key takeaway I touched on earlier, this technology is very accessible. It's, as I say, TensorFlow, open source, free. It's very accessible. And the range of applications, there's a wide range of applications, and the power there that Ryan touched on, this could automate the detection of insulators en masse. You could load up bulk jobs of thousands at a time and just really speed up the process and remove the need for human interaction for the most part. So yeah, interesting and exciting space.
Yeah, look, I think you've nailed it. I mean, I think this stuff's accessible now, whether you're in the open source world, whether you're in the hyperscalers, the Microsofts, the Googles, the AWSs. There's technologies available. You just choose who you want to consume it from. You can operationalize it into your SAP landscape. Look, I think we're really at a point now where we can all get into this stuff. It is accessible, and it's something that we can bring into our businesses. Thanks, guys. Really appreciate your demo and your efforts. I think there are a lot of questions people would love to ask you.
Oh, thank you. Thanks, Steve.